Hello, B.Sc. final year students. So I am Dr. Jaganure. Today I want to discuss the new topic, theory of gravimetric analysis for your class. As already you have seen the syllabus. So for your syllabus, 3 topics already I have decided to take. One is the theory of gravimetric analysis, green chemistry, and organic synthesis via enolates. Organic synthesis via enolate is completed, and theory of gravimetric analysis involves principle of gravimetric analysis, supersaturation, Van Wiener equation, then condition of precipitation, co-precipitation, post-precipitation, supersaturation, saturation, etc. and the steps involved in the gravimetric estimations like washing, weighing, drying, etc. So with this point, let me move on to the next slide. That is the first slide. What is gravimetric analysis? So when you talk about the gravimetric analysis, let us see the picture consisting of Buchner funnel holding a filter paper in a conical flask, and it is connected to vacuum pump. Okay, so this is a simple instrument that is needed for gravimetric analysis for almost all cases. So analytical chemistry involves the analysis of material in order to identify what is present in a sample of a solution. Gravimetric analysis is a quantitative technique that involves weighing of substance to find out how much of substance is present in a given solution. Now let us see the other term, volumetric analysis. So volumetric analysis mainly concerned with the total volume where the substance is dissolved in a given volume of substance in a solution. In case of gravimetric analysis, the substance which is present in a solution is to be determined by calculating how much amount of the substance present in it by means of some chemical steps. So gravimetric analysis was first discovered by Theodore W. Richard during 1968 to 1928. He was the first student to give a concrete idea of gravimetric analysis. Gravimetric analysis also depends upon the mass of the two components containing the analyte. The principle behind the gravimetric analysis is that the mass of an ion in a pure compound can be determined and then used to find out the exact mass by known quantity of impure component present in it. So in the gravimetric analysis, a method of quantitative chemical analysis in which the constituent salt is converted into substance of a known compound and can be separated from the weight. So this is the idea of gravimetric analysis. So in case of gravimetric analysis, how much amount of substance is present in a given solution can be estimated by some technique, that is mass present in it. Now gravimetric estimation is generally done by means of 4 different methods. That the amount of substance present in a solution can be estimated by 4 different methods. One is precipitation, voltization, electroanalytical method, miscellaneous, that is thermographic methods. Okay, so precipitation is mentioned for your syllabus, so wherein the steps involved in it and the overall procedure is to be dealt in your topic. Voltization, electroanalysis and miscellaneous methods, they are not mentioned in your syllabus at present. Okay, so precipitation. What is the meaning of precipitation? Let us see this equation. When you see the calcium ion present in water, by adding calcium oxalate, it will be precipitated as calcium oxalate. I repeat, when you see the calcium ions present in a water solution, then if you add oxalate, so it will be precipitated as calcium oxalate, and how much amount of calcium present in that water can be estimated, and that determination is known as gravimetric estimation of calcium present in water. So for this, calcium carbonate formed in the first equation is subjected for heating, ignition. So on heating, it will decompose to give calcium oxide, CO2 and CO. So here, the amount of calcium oxide formed at the last end of the reaction is to be determined, and the quantity is noted. So this is what we say the precipitation method. So I want to say precipitation is a process in which the ion present in a solution can be converted into a solid particle, PPT, and then it is converted into an unknown mass. Then some chemical methods are used to determine the overall precipitation which is formed during the reaction. Now let us move to the next slide. Well, so for this precipitation method, so let us see, these are the some of the equipments very needed for it. That is a funnel, beaker, set of beakers, and it require desiccator, then filter paper of a high quality. Then you can see in the last stage the digestion of the precipitate, etc. Well, so before we deal all these practical information, let us consider what exactly the terms involved in it. One is a precipitate. Precipitate is an insoluble solid separated from the mother liquor of result of chemical reaction. Then precipitate is an insoluble solid separated from the mother liquor as a result of chemical reaction. Then precipitant. Precipitant is a reagent which is added to the solution to get a PPT. Then precipitation, it is a process in which a precipitant is added to a solution to form a precipitate. Okay. Then the like term, peptidization, coagulation and supersaturations are there. Peptidization, in which the electrolyte concentration in the precipitant layer may be fall below the coagulation point. Then coagulation is a process of forming gelatinous mass by complete or partial solidification of sole. Supersaturation. So this term already you have learned in your previous classes. A solution is generally formed by a reaction between solute and solvent. When the concentration of the solute in a solvent is more, then slowly the concentration of solute will be increases. If it is in a higher maximum content compared to the solvent, then it become concentrated. And finally, if the sparingly soluble substance which is having the solubility product more, then if the high the solubility product, less saturation. If it is a low, the saturation will be more. So like this, one can perform, use these terms during the gravimetric estimations, right? The steps involved in the gravimetric estimations are as follows. So you can see this particular slide. So steps involved in preparation of sample, precipitation, digestion, weighing and washing, then drying or ignition, finally weighing and calculating the exact mass of it. Now for this, you can see the steps. The first step involved in the gravimetric estimation is preparation of solution. This may involve the steps including the adjustment of pH of a solution in order to precipitate to occur quantitatively and get a precipitate of a desired property, removing the interference substances, adjusting the volume of the sample to a unit amount of the precipitating agent to be added. That means if anybody want to prepare a solution, then the preparation of solution for gravimetric estimation involves a standard solution of either molar or normal by using the corresponding equivalent weight or molecular mass. One should prepare a standard solution, that is nothing but a preparation of a solution. Then when you go for precipitation, as already I have quoted in the earlier slide, that precipitation is a process in which a precipitating agent is added to the solution, whereby a solid formation takes place. So the formation of saturation depends upon the relative supersaturation. So relative supersaturation is equal to Q minus S divided by S. So what is this Q? Q is the concentration of the reagent before precipitation. S is the solubility of a precipitate in the medium from which it is being precipitated. Therefore, to get a particle growth, instead of further nucleation, we must take a relative supersaturation ratio as well as the optimum condition for precipitation, which makes the supersaturation low R. So the Q minus S by S, this factor depends upon the following factors. First, precipitation using dilute solution to Q, that is concentration before the precipitation. Then slow addition of precipitating agent to keep that Q as low as possible, Q minus S. Then starting the column during addition of precipitating agent to avoid concentration site and keep Q low. Increase the solubility of precipitation from the hot solution. Adjust the pH of the to increase the S, but not too much increase, as well as we do not want to lose the precipitation by dissolution. Usually add a little of a excess of precipitation agent for quantitative presentation and quick check for complete precipitation. Okay. Now the third step which is involved in this quantitative analysis is digestion of precipitate. So let us see this diagram. Here solution is taken in beaker of a standard known mass, which is dissolved in 250 ml measuring flask. Then a thermometer is kept and is heated slowly, and a reagent that is called precipitating agent is added slowly, and on heating gently one will get a precipitate. So that is digestion of the precipitation starts on heating at an optimum temperature. Otherwise, if you just add the solute and solvent, you won't get any precipitate at a normal condition. But to get the precipitate, so one has to wait and heat the solution for several minutes. So when you heat it, slowly the solute which is dissolved in a solution get converted into a particle of colloidal size first, then colloidal size particles are then converted into a crystalline parts, and these crystals will get settle at the bottom of the container, and these crystals which are formed, then filtered and then dried, weighed, and finally how much amount of the particular amount of substance is present in the given 250 ml of solution can be calculated. So this is what the explanation is there with respect to digestion of the precipitation. The precipitate is left out, that is hot, for 30 minutes to 1 hour for particles to be digested. So digestion involves it is dissolution of small particles and the reprecipitation on large one, resulting into particle growth and later precipitate character. This process is called as a Ostwald ripening. An important advantage of digestion is observed for colloidal precipitation, where large amount of adsorbed ions cover the huge area of precipitation, and thereby the surface area increases and leading to the more adsorption. So one should have an observation how the crystal's growth takes place during the process of digestion, and this digestion requires an optimum pH of an entire solution as well as the temperature condition is to be maintained. The next process involved is washing and filtering the precipitate. So to perform the filtration, we need a specific filter paper which is having high precision. That means the filter paper must have a high mesh size, and generally the filter paper number 41 is used for the filtration of calcium or iron or aluminum in regular practicals. So the filter paper should be designed in such a fashion that it should possess large number of mesh size with small porous holes. Okay, then porous filter paper, then vertical clamping on the stand, then porcelain dish. So these are the requirement for filtration. Then washing. So whenever the precipitate is filtered, the washing material is essential used. That means the washing material, generally water is used for washing, but some of the time the water is not sufficient. In that case, instead of water, one has to use the other substances like ammonium chloride, ammonium nitrate, or sometime the other basic solutions for washing purpose. The washing material which is used for any filtration is of that kind that it should not dissolve the PPT in the solution. If it dissolves, then the result will be of no use. Therefore, the washing material should be of that kind. It should not dissolve the precipitate. It should not dissolve the precipitate, and at the same time it cleans the impurities present in the precipitate and make the precipitate free from the impurities. And it will take impurities only but not the PPT. So all these are the certain conditions required for washing of the precipitate using particular solvents. Then the last one steps involved in this process is drying and ignition. So drying ignition is a process. Drying or ignition is a process in which whatever the amount of this solution filtered in the filter paper is supposed to be heated around 150 to 200 in a normal condition, or else it should be heated around 600 to 1200 degrees centigrade in a proper way. So this can be achieved just by heating on a burner, or it can be done on using some heating standard instruments, either electrical or the big materials. So this drying or ignition is a process in which the wet material is first dried by using hot air cone. So after hot air cone, when it is used, then it is subjected for removal of the moisture. Once the moisture is removed, then previously weighed crucible is taken. In that crucible, the material which is to be ignited is kept and heated strongly, either by electrical or by normal heating process. So this can be achieved by heating the substance for about 1 to 2 hours, sometime more than 2 hours, to get the final product which is completely dry. And during, in this case, whatever the filter paper number 41 I have told in the earlier case is ashless, weightless material. So when you heat it at higher temperature of more than 150, it will automatically remove off, and only the residue left is your quantity or the weight of the substance. So which is weighed by chemical balance or electronic balance, and finally it is 100% pure. Purity is confirmed by just weighing in a proper way. So this can be achieved by some routine methods. So I will discuss rest of the part of this topic again with the beginning in the next episode. So with these few words, I want to conclude the today's session. So gravimetric estimation is nothing but it is the estimation of the substance in terms of mass in a given solution, which generally can be done by a method called precipitation method. This precipitation method involves the totally 6 different steps, and the steps which already I have shown, one is precipitation by adding some particular solute to it, then filtration, then ignition, then drying, ignition, then finally weighing of the substance. All these can be achieved in a proper way by using set of the rules set by gravimetric estimation. Now next time we will discuss all these things in detail. Thank you.